Alright, hey guys. Yeah, maths. Let's do some maths. We're gonna be doing FP2 AQA. I haven't said that yet in any of my videos, so if you don't know Excel, you're screwed. Sorry about that. Yeah, FP2 AQA June 14, question 8, I believe. It's about integration. It's got a really nasty finish, although I'm not quite happy with my head being there. That's not what I was going to say. It's got a really nasty finish, although the first few marks are all from the formula booklet. So, swings and roundabouts. Let's get on with it. A curve has equation y equals 2. Yeah, that's what it. Y equals, I'm sure that'll come up on YouTube. Y equals 2 multiplied by the square root of x minus 1. That's the curve we're using. You could quickly sketch it out. You should be able to do that. Let's see if I can. So, little sketch here. It's root x, so I'm only going to do the top quadrant. Let's have a look. So root x would look like this. Root x minus 1 is going to send that to the right one. So root x minus 1 would look like this. And 2 lots of root x minus 1, it's going to stretch it out by a factor of 2. So 2 lots of root x minus 1. Oh, okay, whatever. It looks like that. 2 lots of root x minus 1 looks kind of like that. And we want the length of the curve between x equals 2 and x equals 9. So we want basically the length of this arc here. We want the length of that arc there. Well, like I said, this is in the formula booklet. Go open up your formula booklet, look to integration. It shows you the formula for arc length. So I'm going to go to my formula booklet that I've got open on my laptop on one of the tabs. There we go. And integration arc length is on page 8. Using Cartesian coordinates like we are, we've got y and x, those are our old Cartesian coordinates. So the arc length, S, why have I changed to black? Oh, maybe it'll show up better. S equals the integral of the square root of 1 plus dy by dx squared. So all we need to work out the arc length then is to find dy by dx. This is a chain rule. And because you're all doing further maths, I'm going to talk through it. I'm not going to do it in all the stages, I'm just going to talk through it. Root x minus 1 is x minus 1 in brackets to the power half. So how do we differentiate that using the chain rule? We bring the half down, that's going to multiply with the 2 and just cancel it out, giving you 1. And then we decrease the power by 1. So that power that was a half is now minus a half. So dy by dx is x minus 1 to the minus a half. A nicer way to write that is 1 over the square root of x minus 1. Negative powers, you take them to the bottom into fraction and make them positive powers. So dy by dx is the square root of 1 over the square root of x minus 1. So in this case, our arc length S is equal to the integral of the square root of 1 plus this squared. So 1 over the square root of x minus 1, and everything in that bracket is squared. And if I go back to the exam, I can see the answer that I've got to get it to. Basically, I've got to make this all one fraction. One quite nice thing is I've got this square root, but I'm going to square it as well. That's going to be quite nice. I'm going to do that now. So we've got the integral of the square root of 1 plus square the top, 1, square the bottom, x minus 1. And then, like I said, I've got to make this all into one fraction. How do I do that? I make the denominators the same. So this 1 is x minus 1 over x minus 1. And now I've got the denominators the same. So it's the integral of the square root of x minus 1 over x minus 1 plus 1 over x minus 1. Cool. And that gives me the integral of, now my denominators are the same, I can combine the fractions the square root. X minus 1 plus 1 is just x. And there we go. The integral of x over x minus 1 dx. I forgot all my dx's. Oh my god, if I was one of my students, I would have got slapped by now. That's not true. Dx's should have been there, should have been there, and should have been there. And should have been there. Oh well. Cool, that's part A. That's 3 marks. That's alright. Part B is in the formula booklet as well. What is cosh minus 1 of 3? It's a show that question. So the answer's in the exam. Cosh minus 1 of 3. Just going to see if I've got a slightly better black pen. Definitely not that one. Yeah, that one's better. All right. Okay, so the formula booklet, going back to the formula booklet. Page 6 now, I think. No, page 5. Yep. Tells us, under hyperbolic functions, there it is, that cosh minus 1 of x cosh minus 1 of x is equal to ln of x plus the square root of x squared minus 1. So in this case, cosh minus 1 of 3 is equal to ln of 3 plus the square root of 3 squared, which is 9 minus 1, so the square root of 8. Oh, I can do one thing with that. It's not looking like the answer just yet, but I can do one thing with the root 8, because I know it's got a square factor. 4 is a factor of 8, so I can bring the 4 outside the square root, where it becomes 2. So that's ln of 3 plus 2 root 2. But that isn't what the answer says. Damn. What are we going to do? How am I going to get that to what the answer tells me? I can't quite see it at the moment. That's a lie, I can, but let's just pretend. I can't quite see it at the moment. So if you're ever in that situation, you don't know what to do. Start at the answer and then see if you can try and get the answer to this. So if I have a look at the answer quickly, and in the exam you can do this on a spare bit of paper, I guess, if you don't want the examiner to see that you're kind of cheating. It's not really cheating, the answer's there. I mean, this is why they give you the answer, just to give you a little bit of that. So the answer is 2 ln 1 plus root 2. Oh, what can I do with that 2? I can bring it up not there, I can't write it there, definitely not. I can make it the power using my rules of logarithms. So that's ln of 1 plus root 2 squared. Maybe brackets here as well to make it a little bit neater. 1 plus root 2 squared is ln of 1 squared is 1. Root 2 times 1 is root 2. 2 lots of that would be 2 root 2. And then root 2 squared is 2. So I've got ln of 3 plus 2 root 2, which is what I had earlier. So now all I need to do is just replay these steps backwards. So this goes to this, which goes to this, which gives us our answer. So if you ever get stuck in situations like this, just look at the answer, see if you can kind of bridge the gap between the answer and what you've got at the moment. It just helps out sometimes. So yeah, okay. That was the formula booklet part of this question. 5 marks, not too bad. The 6 marks though are very tricky. Well, yeah, they're pretty tricky. The last of those 6 marks is extremely tricky. It takes a long time. Let's have a look at it. Okay, so we've got to integrate S, which is what we worked out in part 1. So S was the integral between 9 and 2 of x over x minus 1 dx. And we're going to use the substitution x equals cosh squared theta. Okay, so let's start substituting. Whack that into here. S is equal to the integral between 9 and 2. Now, whenever I'm doing substitution, because I've got a pretty rubbish memory, sometimes I forget that these limits were x limits, and I can't use them with theta later. So to stop myself making that mistake, I'm just going to write x equals 9 and x equals 2 each time until I actually change them to theta limits, because then I'll remember, then I won't make that mistake. Okay, the square root of cos squared x, that's quite nice, we've got a squared under the square root, I like that, over cos squared x minus 1. Oh, now that's making me really excited. Whenever I see a trigonometric squared and then a plus or minus 1, you know, I know we're in business. Dx, but we want to bring d theta in here somewhere, so we multiply that by 1, d theta over d theta, haven't changed it, and then I just move d theta over here. So that's dx d theta d theta. Okay, what's cos squared x minus 1? I said it got me excited. How am I going to work out what exactly it is? Like I said, I've got a bad memory. I only remember one trigonometric identity, and then I remember a rule that can transform them. The one that I always remember is cos squared x plus sine squared x is equal to 1. That's my starting point, and then I just find the other rules based off that. Now, I know that when I change to hyperbolic functions, if I ever have a sine multiplied by sine, I need to make that negative. So if I make this hyperbolic with cos squared x, now because here I've got a sine multiplied by sine, it's sine squared, but it's not always going to be that. I've got a sine multiplied by sine, so that changes to minus sine squared x equals 1. Oh, these are all thetas, aren't they? God's sake. Theta. I'm lucky I've got a whiteboard. You know, if I did this on pen and paper, I would have ripped it out and had to start again. So I want to make these thetas as well. Okay. Here we go. So cos squared theta minus 1 is equal to sine squared theta. Cool. I'm going to pop that in my integral. So I've now got the integral between x equals 9 and x equals 2 of the square root of cos squared theta over sine squared theta. It's looking really nice. And then I'm going to multiply that by dx d theta. So that's the derivative of cos squared theta. Again, because you're FP2 lot, I'm just going to speak that through using the chain rule again. Cos squared theta, bring the 2 down and reduce the power. That gives us 2 cos theta. And then multiply it by the derivative of the inside. I forgot that earlier. I did forget that earlier. See, I do have a bad memory. Earlier, the derivative of the inside was 1. I got really lucky there. It's not 1 now. If I forgot that, I would have been in trouble. 2 cos theta multiplied by the derivative of the inside, which is sine theta. So 2 cos theta sine theta d theta. Cool. Right. I've got a squared and I've got a squared. I could make this into cot squared theta. Cos over sine, I can't make it into cot. I can make it into cof squared theta and then do the square root on that. But because there's cosish here and because there's shines here, I think this shine is going to cancel out with this shine. So I kind of want to keep it as cos and shine at the moment. So I'll do the square root. So s is equal to x equals 9 over x, not over, between x is 9 and x is 2, of cos theta over sine theta times 2 cos theta sine theta d theta. And now I was right not to write cof because the shine cancels out with the shine, and that's going to give me 2 cos squared theta. So s is equal to the integral between x is equal to 9 and x is equal to 2 of 2 cos squared theta. Okay, we can't integrate cos squared. We can't integrate any of our trigonometric expressions squared. We've got to find a way to get them into a trigonometric expression that isn't squared. We do this using the double angle formula, which is in the formula book. Hooray! Another one I don't bother to remember. So, the formula book tells us, and I'm going to use it in theta, that cos 2 theta is equal to cos squared theta minus sine squared theta. This is under the double angle formula. I've done one step in my head, but you should be able to see what's going on. Okay. So I'm going to be able to get my cos squared here into something with cos, but I've still got a sine squared. Ah, it's right on the light, isn't it? Oh, hang on. Hang on. If I just hold my body there, you've got a little bit of a shadow. So you can see what's going on. Right. Sine squared theta is 1 minus cos squared theta. So cos 2 theta is 2 cos squared theta minus 1. Yeah. Yeah, sure. And that means that 2 cos squared theta is equal to cos 2 theta plus 1. I changed into hyperbolic here, and because there's no sine multiplied by sine, I don't need to do anything with the signs. That's really confusing, isn't it? I don't need to do anything with the plus or minuses because there's no sign. Okay, cool. Alright, so I'm now going to rewrite 2 cos squared theta, and I'm going to go back up to the top of my board to do it. I'm going to get rid of everything else. Okay, here we go. Buckle up. So the integral S is the integral between still x equals 9. I've still not changed it yet because I've got other stuff to do. 2 cos squared theta is cos 2 theta plus 1. And really now I need to integrate. There's nothing more I can do except the very last step, which is to change my limits. So remember that x is equal to cos squared theta. So if x is equal to 9, we square root both sides, and x has to be positive, so we're not interested in negative square root. So 3 is equal to cos theta, which means that theta is equal to cos minus 1 of 3. Hang on. Cos minus 1 of 3. I've seen that better before in part B. That's going to help me out later. And the other one is cos minus 1. So when x is equal to 2, square root the x, do cos minus 1. So it'd be cos minus 1 of root 2. We haven't seen that before. That's a little bit annoying. Oh well. And the integral is the same. Cos 2 theta plus 1 d theta. Integrate that. Should be no problem for you guys. That's a half sine 2 theta plus theta. And that's between cos minus 1 of 3 and cos minus 1 of root 2. And now we expand that expression to get to the answer. Oh, I've lost my pen lid. Restart the video. Right, yeah, expand this to get to the answer. So that's a half sine of 2 cos minus 1 of 3 plus cos minus 1 of 3, and we know what that is from part B, minus a half sine cos minus 1 of root 2, we don't know what that is, plus cosh minus 1 of root 2. And we've got to get this whole thing now into an expression just using logs. Okay. Now, I'm going to show you how to do it, don't worry. But at this point, if I were doing the exam, I would be fairly confident at this point I've got 4 marks out of 6. As it actually happens, as it actually turns out, by this point, we've got 5 marks out of 6, but you might not notice. I think it's very, very safe to say you've got 4 marks out of 6. Really, because this takes so long, leave it to the end of the exam. If you've got, it's the kind of thing you want to do. If you've got any time, come back to it. Don't do this missing out a whole nother question. That's silly. Just think, okay, 2 cosh minus 1 of 3, cosh minus 1 of root 2. I can make them into logs, but I know it's going to take a long time. I know it's going to be kind of complicated. It's about 6 lines of, work for only 1 extra mark, as it turns out. Like I said, you might have thought it was 2 extra marks. I probably would have done. Playing it safe, you know. It's only actually 1 extra mark at this point. So we've got 5 marks out of 6. So like I said, I would recommend you stop here. Make sure you've got the bulk of all the other questions that you can do. Then if you've got time at the end, firstly, well done, because it's FP2. If you have got time at the end, come back to it and do it. Can't believe this video is already at 21 minutes. God, time flies. I hope YouTube... Yeah, I'm sure it'll be fine. Right. Cosh minus 1 of 3. From part B, you can rewrite that straight as a logarithm now, okay? What I'm going to do, if you can do that, you can do this as well. Just following the same process that you did in part B, you can get that into a logarithm. I'm going to show you now how to turn this into a logarithm. And I'm going to let you do the rest for yourself, because it is just the same after that. Okay, so starting at the top again. Now this trick is the same trick for a shine of a cosh or cosh of a shine. This is the same trick that we're doing here. And it comes back to the definition of shine. If you remember, the definition of shine is a half e to the x minus e to the minus x. Always think it's weird that shine, like the base one, is the one with the minus, but yeah, whatever. That's the definition of shine. Okay, and that's going to come into handy. That's rubbish. It's going to be useful in writing this as a log. Okay, so this is a half shine 2 cosh minus 1 of 3. What we want to do is make everything in the inside bracket a single logarithm, because when we do that, the e to the x will cancel out the logarithm. And we go back to part B to help us do this. So this is a half shine 2 lots of... And now in part B, cosh minus 1 of 3 is 2 ln 1 plus root 2. So I'm going to get rid of that 2 and make it 4 ln 1 plus root 2. Now we're not quite there yet to apply the trick, because remember, we need the inside of the bracket to be a single logarithm, but we know the rules of logs. We can pop that 4 up there. So we've got a half shine ln of 1 plus root 2 to the power 4. Okay, now e to a logarithm, e and logarithm are just inverses of each other, the natural logarithm, and that's what they always mean when they talk about logarithms without a base. Well, actually, no, it says ln in the question, so what am I on about? It has to be the natural logarithm because it's ln. Ln is the natural logarithm, ln is cancelled out by e's. So e to the x in shine x, if x is ln 1 plus root 2 to the power 4, e to this just gives us 1 plus root 2 to the power 4. So this is equal to a half, and now I'm going to use the definition. Multiplied by a half, and you know, I'll make it easy for you, I'll write it out, e to the ln of 1 plus root 2 to the power 4 minus e to the minus ln 1 plus root 2 to the power 4. Before you can get rid of the minus, bring the minus up to the power. So it's e to the ln 1 plus root 2 to the minus 4, and that is a quarter. E's and ln's cancel out. 1 plus root 2 to the power 4 minus 1 plus root 2 to the minus 4. Do that with the other sign expression. You know what cosh minus 1, 3 is from part B. You can work out what cosh minus 1, root 2 is by following the same method. They all cancel out to give you the answer. If you're in the exam and you're running out of time, just write the answer down, because it's only 1 mark. And if you've done all the rest of the other stuff, yeah, you know, yeah, give them a tick, whatever. Or her. Right, yeah. Let me know in the comment box if you've got any questions or thoughts, or you just fancy a chat, you know, whatever. And let me know if you want me to look at any other questions or anything. Okay? Good luck, guys. Yeah. Oh, shit.